Welcome back. Oh, she went home.
Oh, she's not feeling well?
I guess now she realized.
Vegan.
At the end? I'll see at the end. Like, subscribe, turn on the bell notification, comment your favorite math equation. It probably can. Yeah, I think so. I don't know, but sometimes when I listen to some of the videos, it's actually mostly very muffled. Unless somebody is
If you need more time, later submit the homework to that stack yourself. Alright, remaining 20 minutes, I want to introduce how to differentiate logarithms. Okay. Differentiating logarithm is not intuitive because when you differentiate ln x, usually we do ln rather than your common ln. Okay, so usually we will do ln. Differentiating ln x itself will give you 1 over x. Okay, so that is what I mean by not intuitive because it totally gives you something different. Alright, so if I have differentiation of maybe ln 4x plus 3. Okay, so instead of x itself, if I'm differentiating ln 4x plus 3, how would that look like? It will have to be 1 over 4x plus 3, following the similar structure. But not forgetting chain rule itself will tell us we always have to differentiate the 4x plus 3. And when we differentiate, we're always multiplying. So we multiply by 4. And that simplifies to 4 over 4x plus 3. Okay? So in other words, if I am differentiating a function, a ln of a function, okay, I will get 1 over that function itself and multiply with the differentiation. Okay, so those are your rules for logarithmic differentiation. Okay. Any questions so far? So those are the rules. So looking at try 8 part A. If I let y equals to x plus 1 times ln x, to differentiate, we apply our product rule. So keeping the left side x plus 1, differentiating the right 1 over x, plus keeping the right side, differentiating the left, we will get a 1. Okay? And this could be simplified to x plus 1 over x plus ln x. Come in. If I want to differentiate ln x over x. So ln x is a function, it's together, you cannot cancel out the x. Okay? So if I let's say call this y, then your dy over dx, using your quotient rule, keep bottom, differentiate the top, minus away, keep the top, differentiate the bottom over bottom square. Simplifying this, we have 1 minus ln x over x squared. Okay? This one is something similar that I've already done. Okay, so we know that differentiating the logarithm, I will have 1 over 2x plus 4, and differentiating 2x plus 4, I have 2. Okay, so if you're quick enough, you can form this already. Otherwise, just multiply and simplify. Okay, but then, is this the simplest form? No, okay. Denominator is 2x plus 4, so can be simplified by dividing by 2, top and bottom. You should get 1 over x plus 2. Okay. So do have that awareness that we need to leave our answer to simplify. Part B, we have exponential inside our logarithm, but rules still apply the same way. Differentiating ln, you get 1 over e to the power x plus 1. And then we need to differentiate the e to the power x plus 1. Differentiating exponential is just the same exponential itself. Differentiating 1 is just 0. Just intentionally going to write that there. And we will have e to the power of x over e to the power of x plus 1. This cannot be simplified further. You cannot cancel like that because down here got a plus. Okay? It must be having a common factor throughout, just like what we have over here. Okay?
Oh, it's very nice.
No, I think it's because you forgot the grades. That's all Chinese.
Okay. Now, this one, logarithm of x plus 1 bracket square, I want us to be able to know that ln x plus 1 square, okay, means that we're looking at logarithm. The things inside the logarithm is x plus 1 times x plus 1. It is not the same as your ln x plus 1 whole thing squared. Okay, they are not the same. So do be careful about how the brackets are being placed or whether the brackets are there or not. Because in this case, what this means is ln x plus 1 times ln x plus 1. So there are 2 logarithms. Okay? So do be aware about that. There are 2 ways to get around differentiating this y equals to ln x plus 1 square. I'm going to show you 2 methods. One method is that we just keep to the rules. It must be 1 over the entire function, that is 1 over x plus 1 bracket square. Then we differentiate your x plus 1 square. I should draw my line here. Okay, that will be bring down the 2 times x plus 1 power minus 1 differentiate x plus 1. Okay? So this part here is your differentiate differentiation of x plus 1 squared. Right? So they're all multiplying each other, so I can cancel out one of the x plus 1. Okay, so I will have 2 over x plus 1. So this is one way. The other way to solve it is to make use of your logarithm laws first. Okay? So if you recall in your logarithm laws, maybe referring back to what you have in your formula book. Okay. One of our laws is that if I have the power inside the logarithm function, I can bring down the power and write it this way. So that is possible for this one, whereby I can write it as 2 times of ln x plus 1. Okay? Then, it is just a constant number multiplying your logarithm. I will keep my constant number there. Differentiate my logarithm, that is 1 over x plus 1. Differentiating x plus 1 is just 1. So this is your derivative of x plus 1. And then it simplifies to 2 over x plus 1. Okay? So I'm showing you two methods. One is to actually differentiate by brute force. That means whatever that you know, you continue to apply your chain rule. The other one is that you simplify it using your logarithm laws first, and then you go about differentiating. Okay? Knowing both methods will be helpful, especially the second method. Because why the second method is important is that when you have a function like part D, y equals to ln x squared sine x over x plus 1, it is not possible for us to solve by brute force anymore. Okay? Because it is definitely tedious. What this will mean if you want to solve using the first method is that you want to see as 1 over x squared sine x over x plus 1. And then you have to go about differentiating this entire thing. Okay? Need to differentiate, and you have to use quotient rule. Not only do you have to use quotient rule, you still have to do product rule in the numerator because it's x squared sine x. I'm not going to explore that because I confirm will make mistakes. Okay? So I just want us to know that I will have 1 over the entire thing, and then after this you have to differentiate. Very, very tedious. Okay? So it's not feasible. Therefore, what we need to do is to apply our logarithm laws, not just this one, okay? Our other logarithm laws in order to simplify this part first. Okay? So the laws that we will be using will be this one. As well as this one. Okay? We need to remember that when inside the logarithm, if they are multiplying each other, we can split it out into addition of 2 logarithms, and if it is division, we can split it apart in order to do your subtraction of 2 logarithms. Okay? So how will this work on this function? Okay, so this one don't go on. Okay. What we will first do is that recognize this entire thing as a fraction. We use this second one over here. I'm going to split it out into two separate logarithms. So ln of x squared sine x minus away ln of x plus 1. Okay? Then, this is a product of two things. I can use the first one. That is ln x squared plus ln sine x. Okay? Minus ln x plus 1. And then your ln x squared, I can use this concept here, this law. Okay. Being able to simplify it to this extent will definitely help us in terms of our differentiation. Because to now differentiate, we will differentiate one by one. So 2 ln x will be 2 and 1 over x. Ln sine x will be 1 over sine x, followed by the differentiation of sine x, minus away 1 over x plus 1. Differentiation of x plus 1 is 1. Okay? And then we tidy things up. And cosine over sine is cotangent. Okay, and we get this. Alright? Okay, I want you to go back home. Okay, to do these questions in your notebook to practice your differentiation for logarithm. Okay, question 1a, b, c, d, and 7a, d, f. Right? Please do this at home so that tomorrow when we come back, we can run through any pressing questions. Okay? And then tomorrow, I definitely want to close out this entire chapter 15 and move on to e-maths next week. Okay?
Thanks for watching, guys. Remember to subscribe and hit that bell notification. At 1 million subscribers, we'll do a giveaway.
Give away the camera.
Make sure to like and subscribe.
We'll give away our map.
Reggie will give away our memo.
I like the camera. No.
Any more homework not yet submitted? Okay. And that's all for